Let's take a look at another analysis. This time we're going to take a look at an alternative file. This lists the average hourly earnings by program and work term for UWaterloo students for the winter 2019 term. However, this data is in a slightly different format to illustrate some localization issues. So let's take a look at this file. First, we'll quickly eyeball it in our Variable Explorer here. I'll go over to the Files tab and double-click Co-op Salary 2019 FR.csv. And we see this file looks quite a bit different from the one that we were just working with, doesn't it? Pause the video now. Take a look at the file. What issues can you spot? Well, let's see if we can find some using pandas and Python. I'm going to start in a clean file and read in salary data into a new data frame. Well, this time I can see that our term is in a different format. Salary is in a rather interesting format. Looks like we have a Sentinel value. Doesn't look like we have any numeric columns. If we try to print out salary data.describe, in this case, I get details about all my non-numeric columns because all of my columns look like they're non-numeric. Let's confirm that to ourselves with salary-data.dtypes. Look at that. Program, term, and salary are all object. So we're dealing with non-numeric data. So just to review, it looks like we have -1 values for our salary column. Our salary column has been read as a string. We've got commas in the salary, and our term column is in a new format. So we're going to need to fix all of these problems. So first, let's try what we did before, which is trying to convert our salary column into numbers. We use pd.toNumeric, although you might already see that we're going to run into some issues. But let's try it anyway. This is a good first step. So I'll extract a copy of my salary data column, and I will try to convert this to numbers. pd.to_numeric. I'll pass in my salary column. We'll just try running this, and we run into the error, unable to parse string 15,9 at position 0. Drat, we can't convert this data. Now let's pause for a second and talk about this string that it's unable to parse. So pandas could not convert this value into a number. Now, when we compare this file against the previous file, something should strike you as different right away. In the original file, our first row was Applied Health Sciences, Term 1, $15.90 an hour. In our new file, we have Applied Health Sciences, Term 1 of 6, and then 15,9 is in quotes. What's happening here? Well, let's try to answer a separate question. Take a look at these two numbers. Are they equal? Pause the video and think about this for a moment. For learners that are outside of North America, or for learners that are in a different locale, you might come up with a different answer than others who may be inside of North America, because it depends on what you're using for your decimal separator. Not all locales use the period character as a decimal separator. Some locales, for example, Spain and France, use the comma as a decimal separator. So, does 500, 150 equal 500, 150? Well, it depends on the locale. In other locales, such as Switzerland, they use the apostrophe character as a thousand separator. So 500 apostrophe 150.00 is 500,150. So whether or not the comma or the period or an apostrophe represents your decimal separator depends on the locale that you're in. So in our case, we're going to assume that this file was produced on a computer in the French locale and that our comma in this file is a decimal separator. Let's see if pandas can handle that. So let's try to coerce our salary column into numbers. We're going to do errors equals coerce like we did before. Let's see what happens. We'll come back into Python here and we'll say errors equals coerce. And let's take a look at the salary column. This doesn't look right, does it? So we have -1 got converted, but everything else is not a number. Why is that? So this is a quirk with pandas. It's not aware of localization issues. It couldn't parse 15,9 or any of the other salary data with a comma in it as numbers. And just like we asked, pandas gave us back NaN. Well, that's no problem. Remember in the last video, we used the replace function to replace ARCH with the word architecture. So let's try replacing the comma with a period. This ought to work, right? Well, let's jump back into Python and try it. And for the moment, I'll comment out line 11 by putting a hashtag or a number sign in front of that line. And I'll now say salary call equals salary call dot replace. And we'll try to replace the comma with a period. And the result looks like nothing happened. Those dastardly commas are still there. What happened? Well, here's the problem. The replace function was looking for just commas. It was looking for salaries that were equal to just the comma character. It was looking for an exact match. There are ways to get replace to look for different parts of our string, but it's a little bit easier in this case to use a slightly different method to remove our comma. What method is that? Well, it's the string property on our data frame column. This will grab each data frame column's value as a string, and then we can use the strings replace function to replace our comma with the period character. So check this out. So instead of salary call.replace, I'm going to see salary call.str.replace. This is going to search for the comma character and replace it with the period character. If I run this code and take a look at salary call, look at that. We have period characters for our decimal separator. Now we're ready to run this to numeric, aren't we? No errors this time. If we look at salary call, we have -1s. But -1 is a sentinel value, isn't it? We need to deal with this somehow, don't we? So in a future week, we're going to learn how to filter out any -1 sentinels without having to clean this data. For now, we're going to take advantage of the fact that if pandas can't parse a number, it'll turn it into NaN. We're going to replace any -1s with an empty string. In fact, we could replace it with anything that was not a number. Then we'll run pd.toNumeric, coerce any errors to not a number, and then we will have our cleaned column. Let's try this. So I'll come back into Python, And between these two lines where I'm replacing the comma with the period character and doing pd.toNumeric, I'm going to add another step. I'm going to say salary call equals salary call.str.replace. And we're going to replace -1 with the empty string. I could replace it with anything. I could replace it with the word garbage. If I run this code now, any entries where we had -1 will now be turned into NaN. Take a look. We have NaN where we had -1. But we're not quite ready to run our regression. First off, we need to put our salary column back into our data frame, don't we? Let's do that. I'll say salary data.salary equals salary call. And if we look at our salary data frame now, salary is now a numeric data type. Now we can prove it to ourselves. I'm going to copy this print of our salary data types. I'll paste it underneath where we've done our data cleaning. And look at that. Salary is a float 64. In other words, it's a floating point decimal number. But we're not yet ready to run our regression, are we? What data type are we dealing with term? It's an object. It's not a number. So we're not ready to run a regression yet. However, we've dealt with a lot of problems already. We've removed the sentinel values. Our salary has now been turned into a number. And we've dealt with replacing the commas to our locale-specific decimal separator. The next thing we need to do is clean our term column and turn that into a number. And we'll do that in the next video.